Hey guys, let's discuss this problem. So it's also a 1800, and we are going to start with the examples here. And the first number is the number of people in the row, right? So we have two people in the row, and they line up like this. The first place is occupied by person one, and the second place is occupied by person two, right? And we can switch their places as long as we have the pair in the following pairs, right? For example, can we switch these two guys' places? The answer is yes, because this pair is in the following array, right? So that we can switch their places and get a new row like this. And our goal is to move the last um, person forward and as forward as possible, right? In this case, we move two to the first place, right? And so that we output the final answer, which is one, because we move the last digit to one step to the front, right? So let's take a look at the second example here. So in this case, we are going to have three people, right? And the initial row is like this. The third person is at the first place, and the second place is occupied by the person one, and the third place is occupied by person two. So we want to move two uh, to the front, right? Um, and the only pairs we can move, uh, the only pairs we can switch is 1, 2, 3, 1, and 3, 2, right? So can 1 and 2, this pair switch place? The answer is yes, because we got this pair here, right? So we can switch their places and we can get 3, 2, 1, the new row, right? And can we switch these two guys' place? The answer is yes, right? Because this pair is also given by the input, right? So that we can further switch their positions so that we can get a new array like this. So in this way, we move the last digit to the very front, right? So that is two steps um, before the initial position, right? Because currently they're at position one, and initially it was at position three. So we output a two here, right? So let's take another look at example three. So we got five people here, which is 3, 1, 5, 4, 2, right? We want to move 2 forward. So how far away we can move it? So first, let's try switch these two guys. Can they switch with each other? No, because 4, 2 is not in the given pairs, right? So we cannot switch their positions. So can we switch um, 5 and 4? The answer is yes, because 5 and 4 is in the given pairs, right? We can never switch 5 and 2 because we can only switch two numbers that are next to each other, right? And not only they need to be next to each other, and also the pairs have to be appear in the given array, right? So can we switch these two guys? The answer is yes, so that we can have 4, 5, 2 here, right? And then we can switch 2 and 5, right? Because of 2 and 5 is in the given pairs. So that we can get the uh, array like this. So that is the best we can do. So we can move the last digit one step forward, right? So we output 1 here. So that is our problem. So how do we solve this problem? Um, sorry about that. Um, let's take the last example, right? All right. This is our last example. So what are we going to solve this problem? Um, first, this is our initial array, right? And let me make it a little bit bigger. So this is our initial array, and we want to move the last digit forward. So in order to do that, we can have a simple strategy here. So first, we can try if we can move the second last digit to the right of the last digit, right? We can try to move this guy here first. And the only thing we need to check is that if we have uh, if this digit has a pair in the given pairs that leads to the last digit, right? If 4, 2 is in the given pairs, then we can move 4 to the right of the last digit, right? So after we check this guy, we can check if we can move this guy to the right of the last digit, right? Can we move this guy to the right of the last digit? Um, in this case, we just need to check if this guy has those pairs that can lead it from this place to the last digit, right? In this case, the all of the pairs that start with a 5 can end with those digits that is to the right of this number, which is 2 and 4, 2 and 4 here, right? So in this case, we can move 5 to the right of the last digit. That means we can move the last digit to left, one step further left, right? And we can go on to check if we can move 1 to the right of last digit? The answer is no, because we don't have 1, 4 and 1, 2 in the given pairs. Why don't we need a 1, 5 here? That is because we already move 5 to the right of the last digit. So we don't really need to consider 5 anymore, right? Uh, and then we can check 3 to see if 3 is, can we make 3 to the right of the last digit. To check that, we only need to check if 3, 1 is in the given pairs, and 3, 4 is 3, 4 in the given pairs, and 3, 2 in the given pairs. If all those 3 pairs are in the given pairs, we can move this digit to this place, and to this place, and to this place, right? But the answer is no, because not all of the pairs are in the given pairs, right? So that's how we solve this problem. So essentially, we just start from the digit that is uh, closest to the last digit, and we try to make it to the right of the last digit, and try another one, and try another one, and try yet another one. And if we can move one digit to the right of the last digit, we can just increase the answer by 1, right? And remove that number from the array, right? So one tricky thing is that when we need to check if uh, we can move one digit to the right of the last digit, we only need to check for um, all those pairs started with the given digit, right? Let's say if we want to check if 5, we need to first check all of those pairs started with 5, and check how many of them are ended with the given array that is next that is to the right of the current digit, and also um, we need to make sure that that digit is not removed from the array already, right? If it is already removed from the array, we don't need to count it in, right? Let's take a look at the code. So here is the code. We are going to have an array called visit to keep track of those digits we already visited and already know whether we can move it to the right of the last digit or not, right? And we're going to read the initial array, and we are going to save all those pairs. So we are going to save those pairs in the next, right? Next X means that, let's say, next 5 has a array that is um, equals 2 and 4 in this case, right? So next 5 is the pairs that started with 5 and end with these numbers. and we are going to keep keep the final answer in this variable. And need here is that the number of digits that is needed, the number of pairs that is needed for uh, the current number to move to the right of the final digit, right? So in this case, 5 needs 2 pairs to reach the final point, right? And visit, this is the initial visit, right? We set the last digit to 1 so that we can know that in order for 4 reach to the end position, we need to at least have 1 pair that ended with 2, right? And has here is counter that current the counter of the current pairs, right? Let's just iterate all of those um, pairs, and whenever we find a visit j equal to 1, we increase the hash by 1, right? In this case, if we find 5, 2, 2 is visited, so that we increase the hash by 1. And try another pair, 4 is visited, so we increase hash by 1. So in total, hash equals to 2, and the need is also equal to 2. So that that means we can move this current digit to the right of the final digit, right? And if we cannot, that means we need to increase need by 1, and also set the visit of current digit to 1, right? After iterate all of those digits, right, we can just output the final answer. So I guess that's it. Thank you for watching.